So the next thing we want to do is mean value theorem. What does it say? So it says that if fx is continuous on the interval AB, then there exists a point C somewhere where the average height of the function is equals to height of the function at C. Okay. So what it says is if the function fx is continuous in an interval AB, then you should be able to find out the point C where the height of the function at C is equal to the average height of the function. And that is true, right? I mean, since it is the average height, since this is average height, the average height must be somewhere in the middle, right, between the lowest and the highest values. So that is the point C that we are able to find out. Okay, let us see some examples on the use of the mean value theorem. For the mean value theorem, in short we call MVT. Okay, mean value theorem. Okay, so what it says is use mean value theorem to find out C for the function fx equals to x cubed on the interval 0 to 5. So what we do is we use that mean value theorem. So what is A? A is 0, right? B is 5. So 1 over B minus A. So let's write down the solution. So 1 over 5 minus 0 integral. So 1 over 5 minus 0 and then integral. What are the limits of integration? So the limits of integration are 0 to 5, right? F of x is x cubed dx equals to f of c is c cubed. You see that? I'm just plugging into this formula. So I'll find out the value of c. So 1 over 5, you see that? And then what is the integral of x cubed? You'll get x to the 4 over 4, right? And then inside the this is inside the bracket. And then outside we have 0 to 5 equals to c to the cubed. So how much is that? How do I do that? Is just plug in the 5 upper limit. So you get actually 5 to the 4 over 4, right? And then minus 0 to the 4 over 4. See that? Equals to c to the cubed. So what I did is I plug in the upper limit on the x, and then I did minus, and then I plug in the lower limit. Okay, so 1 over 5, so this is or so 1 over 5, how much is that? This is basically 0, right? So this is 5 to the 4 times 5 to the 4 over 4 equals to c cubed, right? So what do you get? So you divide 5 to the 4 by 5, so you cancel one of those. So 5 to the cubed over 4 equals to c cubed. How do I solve for c? Just take the cube root, right? So I would do cube root of 5 to the cubed over 4 equals to c, right? So how much is that? You can distribute this cube root to the top and bottom, right? If you distribute to the top, that 3 and 3 will cancel out, so you'll get 5 over cube root of 4 equals to c. This is what you get. That is the value of c, where the height of the function at c is equal to the average height. Okay, let us do one more example. So use mean value theorem to find out c in the given interval of fx equals to 16 secant square x on the interval negative pi over 4 and then pi over 4. Exactly the same way, right? So what you do is solution. You do 1 over b minus a pi over 4 minus negative pi over 4 and then integral negative pi over 4 through pi over 4 16 secant square x, right? And then dx. What do you get? So pi over 4 plus pi over 4, right? Because there is double negative. So that is pi over 2. So 1 over pi over 2. And then I want to integrate this. I will pull this 16 out, right? What is the integral of secant square x? That is tangent x, right? Tangent x. And then negative pi over 4 through pi over 4. So this is the integral, right? But this must be equal to f of c. What is f of c? Just 16. This must be equals to 16 secant square c. 16 secant square c, right? Because what does the formula say? So you find out the average height, right? And then write down equals to f of c. F of c is just replace x by c there. So what do I get on the left side? It is basically 2 over pi, right? Because this is the 1 over the fraction. So it will be like 2 over pi. Let me write that way. this implies 2 over pi times this 16, and now plug in the pi over 4. What is tangent pi over 4? Tangent pi over 4 is 1, right? And then minus tangent negative pi over 4 will be negative 1, right? So this is what you get. So this is equals to 16 secant square c. Okay, so how much is that? This is basically, this one is basically 2, right? So 2 times 2 times 16. So that is on the left side, you get basically, let me write down here. On the left side, you get basically 64 over pi equals to 16 secant square c. All right, that's what you get. So now how do I solve this? Divide by 16 on both sides. So let me do that. Divide by 16, divide by 16 here. So it will be 16 times 4. So 4 over pi equals to secant square c. Okay, so how do I solve this? Is take the square root. You will get 2 over root pi, right? Because I'm taking the square root on both sides. 2 over root pi equals to secant c, and then take secant inverse on both sides, or arcsecant on both sides. Therefore, c equals to secant inverse 2 over root pi. That is the final answer. Okay, so let me talk about some of the notes on the definite integral and the area. So this function f of x, this is the shaded region, right? How to find out the integral of the fx over x-axis and then between a and b is a to b fx dx. Suppose this integral, value of this integral is 10. Basically, if you are finding the value of the integral or the integral of a function fx under the curve under this curve and over x-axis between a and b, then this is basically the area, right? Area under the curve between a and b. Okay, suppose this value or the integral or the area, this is 10. Then if you flip this, if you reflect this about x-axis, this is the graph you will get. Okay, so do you remember from college algebra that if you are reflecting a function about x-axis, then you multiply the right hand side by negative sign, right? You change the right hand side by negative sign. You see that? So I denoted that by gx, and then I wrote negative f of x. This is just reflecting down, reflecting about x-axis. This is what you get. So can you guess what will be the integral of this over this curve and under x-axis? Just the change by negative sign. Okay, how? Because I want to find out a to b gx dx. Okay, that will be a to b gx is negative fx dx, right? I pull that negative sign out, so a to b fx dx is negative and then 10. So basically what it says is, if you are finding the area below x-axis, that will have the negative sign, or the integral below x-axis, that will have the negative sign. Okay, that's what I wanted to say. Look at this. What is given here is from a to b, the integral value, this value, the integral value is negative 5, because this is below x-axis, so I'm taking that as negative. And from b to c, the integral is supposed 10. Now, how do you find out the integral between a and c? So to find out the integral between a and c, how do you do that? Is you will do a to b integral and then plus, and then you do b to c. Okay, so the a to b is negative 5 plus b to c is positive 10. So 10 minus 5 will be 5. This is what you get. Okay, this is like f dx and then f dx. Okay, some part of the f is below x-axis and some part of the f is the above x-axis. That's why if you want to find out the total fx between a and c, so what you do is you break, and then you separate that below x-axis and separate that above x-axis, and then you add them. So this is negative 5 and this is positive 10. If you add that, you will get positive 5. This is how you get that. But when you do the absolute value, you see that absolute value here? If you're finding the integral of the absolute value of fx from a to c, then absolute value will change all the negative sign into positive sign. So how would that work? Is you will do a to b absolute value of fx and then plus b to c absolute value of fx. okay, dx. If the function is negative, this absolute value will make it positive, okay. So this will become positive 5 instead of negative 5 because of the absolute value is removing the negative side, and then plus this is 10. That's how you get 15. Okay guys, that is one of the note that I wanted to share.